first of all, we're looking at this data, right? We want to check the relationship of iron and potassium. In this data, we have potassium enrichment, right? Somewhere here showing that we have potassium enrichment from our data. Yeah. Let's look at it. Our data here. You see where the issue is. There's potassium enrichment here.
Yeah.
You know, then which is associated with this structure. Then we want to compare our iron, and we'll see also, you see, there's some coincidence of iron around here too. So we want to see really is there any relationship, existing between this and this. Though there's a kind of a shift here, but there's some a close by kind of a relationship within the entire zone. You can see this is where we have oxidation happening. So we want to say use this Spearman's coefficient to check if really there is such a relationship. Yeah, so we've copied this out. We want to rank it. So this is actually what we have here. First of all, we've arranged those numbers. This is the serial number, but we've arranged it from largest to what? To smallest numbers. Largest to smallest number. So we want to, first of all, we are ranking K. We want to rank K, right? Now, looking at this, we can put our ranking here. Looking at this, we have 98523, right? So definitely this is, we'll have it as 1, 2, 3, right? That's what we have. And we need to insert another line here. This is the first 3 ranks we have here. So if we add this and look at here, the sum is 6, the count is 3, and the average is 2. So there will be a 2, 2, 2, right? There will be a 2, 2, 2. Now, 9475 is what? This is rank 4 here. It's just 1, so this will be a 4, right? So this is how many here? 1, 2, 3, 4, 5. So what do? We'll rank. This is up to this standard. So the ranking is from here. So it will be 9. The count is 9. So it's going to be 9, right? So we'll have 9 up to this, right? We are on rank 12 now. So this one is 2, which is, so this is 13 and 14. 13 and 14 is 14, 14, right? The average is 14, so this will be 14 and 14. Then this is what? 15, 16. Average is 16, right? Then this is how many? 20. So that is 19. So this rank is 19. Then we'll still go down. You can see. Sorry. And drag this down. Keep ranking. This is what? 21. This is how many here? See, 4, 8, 7, 8. How many of them? 4 of them. The average is 24. We have 24. Then this is, the average is 27. Are you seeing it? We have 27. Then this it should be 28. Then this is 1, 2. The average is 30. So this should be 30. We keep going, right? This is what?
31.
This is 31. This is 2. So the average is 33. 33. This is how many? 1, 2, 3, 4, 5. Right? 37. Am I correct? No, from here. 36. That is 36. Then go down again. This is 39. 39.
36. Okay, 39.
This is 39.
Yeah.
Then this is how many? This is where it stops here. It stopped at 48, right? 48, right? So it will be up to this. Average is 44. So I have 4. Right. This is 49. This is 50. And this is how many? This is 1, 2, up to this. Oh, okay, let's go down. So we want to rank this. We want to rank 100 of this. This value, we just want to rank 100 of it. You understand? To test, for us to look at what is going on. Now, what do we have here? So this will be discontinued the same number to 35 to this. Yes, we are correct. The average is 73. The average is 73. We'll have this. We'll rank it to 73. Is that correct? So now we're on the 94th number. Okay, now we have what? 95. We have 96. There are no repetition of numbers again, so definitely to 100, right? Now actually we want to deal with 100 data. Okay, then the same thing. Here I can remove those numbers. We can remove those numbers and say now. Okay, now what do we do here? We do the same thing. We use the same thing here. The same method here. We can actually insert this, another number, then we can rank this 1 to 100 over the 100 data. Then this, is there any repetition here? There's no repetition, so we rank 1, rank 2. We've not seen any repetition, so we can be going down until we see any number repeating itself. No, is this really arranged? This is another thing we need to check. from large because I'm seeing 3,500 and this thing here. I'm seeing this. So now we need to arrange this from large to. So what we need to do is that this we can remove this from here. Yes. So we can remove this decay and place it here. And we'll go back to this. So we can remove this and sort this one from what? From large to smallest. You know? Sorted this one. So I think they are well sorted now. 1, 2. We've not seen any repetition of numbers. Have we? Yeah, there is here. There is here. These and these are same. So these and these are same. No, they are not. 6, 9, 6, 6, 6. They are not. They are not the same thing. They are not the same thing. So we can be ranking it down this way. So this one is pretty easy because there's not much repetition of numbers. You see? Is there anyone? We've not seen any repetition of any number. Yep. Not. Okay. Ranking this one is much easier. It's much easier. No number. So this one is much easier. That is the case. Now if you want to check to ensure that you are correct, there's no repeating of any number, you can as well as copy this and place it just for you to check, you know, and place it here and say equal to. They should be giving you 0 minus this. All should be 0. If you have any one that is not 0, then see, so you are correct. Everything a check, quick check. So you can actually remove this. Now we've ranked this. We don't need this again. So we can have our, this copied to this. So we've ranked it now, right? Okay, we can also arrange it in a proper way. Insert. What do we have here? Yes. This rank is for, this is for K rank, and this is iron rank. You understand? So you can actually cut out this and place it here, and have this K rank, iron rank. So what next now? What next do we do? We'll now do the difference, right? Whether you different, whether it's minus or negative, because you're going to still square them, right? So we now have this minus this will give you what? 1. So you can use the same formula downwards here up to this. We'll have this. Now that is the difference of K and what? And FA, right? Now here we'll have the square. Now have d square right, this raised to power 2, right, to be equals to this raised to power 2 raised to power 2, correct? 1, it's correct. This is this, correct? So we'll go down. That's what we have here, right? So what's the next? The sum. The sum of, what sum are we looking at? We are going to do the sum, right? We're going to do the sum of this. I'm going to do the sum of this. The sum of this is this. Right? Okay, now so let's go. The summation of d square, which is this, difference between this and this is this. You know? Now, and according to the Spearman's formula, we have, okay, let's have something like this. So that is the formula we are using, right? So the summation of this is this already, right? So now finally we have we need to get the 6 multiplied by this. This is equal to 1. Bracket open, or 1 minus bracket open, then 6, alright, 6 bracket open, because it's overall, another bracket will open. We'll have 6 multiplied by what? By this. Or we can make it a bit easier. We can first of all get this summation of multiplied by this. We can say this is equal to this multiplied by 6. Right? That is this. Then this is n. How many numbers are we dealing with? This is 100. It means 100 raised to power 3 minus 100. When you open the bracket, it becomes n raised to power 3. It becomes n raised to power 3 minus n when you open the bracket. So this means 100 multiplied by 100 by 100 minus 100. That's correct. Minus 100, that is the number now. N, not 1. This is n cubed, open bracket, this becomes minus n when you open bracket. So the n here is 100. So this becomes 100 cubed minus 100. Is that clear? So that means we now have 100 multiplied by 100 multiplied by 100, which is this. Is that not true? When you now do this, bracket this, for example, and you minus what? 100, which is n. You have this as the denominator, right? This is your numerator now, and this is your denominator, right? This is what you have. Then finally, what do you have here? Become what? This divided by this, is that not? This divided by this will give you this bracket 1 minus this, correct? To have the Spearman's coefficient now becomes 1 minus this, correct? 0.95. This is exact almost 1. So there is a very strong relationship, a positive correlation between the what? Between the iron and potassium. So what it means here is that as far as iron is increasing, then the potassium enrichment, this will increase. Is that clear? So we have 0.95, which is a positive correlation. If we had gotten minus, do you understand? This is like, if you correct this now, what do you have here? If you correct this, what do you have? You have 1. Have you seen it? If you correct to 1 decimal places, you have 1, which is what the Spearman's coefficient is talking about. So in this, it means that there is there is very strong positive relationship between potassium and and iron enrichment in this particular. So as far as the potassium enrichment is increasing in that location, definitely the oxidation. So that's why we can actually say there is a positive correlation between the iron and potassium at this particular point. Clear? So with this method, you can still use that to check other, coefficients. Becomes 1. So with this method, you can use that to check correlation among other data. Clear? Understood? So you can handle other ones, right?